Ancient desert trade routes served as the backdrop for one of history's most sophisticated technological heists. While these paths moved luxury goods, they were also the front lines of high-stakes industrial espionage. A 1,300-year-old wooden panel, recovered from the sands of the Taklamakan Desert, preserves the blueprint of how that theft was executed. For centuries, China controlled the entire supply of silk. The emperors protected their cultivation techniques with aggressive border checks, making the export of silk-producing secrets a capital offense, punishable by execution. Breaking this monopoly required more than a stolen design. Thieves had to transport a living, fragile biological ecosystem across thousands of miles of hostile territory. The king of Khotan targeted this industry through a strategic marriage. He wed a Chinese princess, convincing her that his kingdom would be her new home, and it desperately needed its own silk supply. To move the contraband, the princess used the one place border guards were culturally forbidden from searching, the interior of her own elaborate royal hair bun. She packed silkworm eggs alongside seeds for the white mulberry tree, the only plant these specific insects can consume to produce high-quality fibers. The artwork on the panel centers on the figure of the princess, drawing focus to her unusually large, ornate headdress. To her left, a maid points directly at the princess's hair, isolating the location of the hidden cargo. This small artifact serves as a permanent record of the operation, documenting exactly how the secret of silk finally escaped China's borders. Acquiring the insects was only the first hurdle. Producing a single strand of flawless fabric required a lethal intervention in the silkworm's life cycle. Inside its cocoon, the silkworm transforms into a moth. If allowed to hatch, the moth chews through the silk casing to escape, tearing the continuous fibers into useless fragments. To prevent this, the standard Chinese technique requires boiling the chrysalis alive inside the cocoon. This allows weavers to unspool the cocoon as one pristine, unbroken thread. A single cocoon can yield 900 meters of silk, a distance nearly equal to the height of the Burj Khalifa. The strength, softness, and value of Chinese silk were the direct results of this uncompromising industrial process. However, the Kingdom of Khotan was a Buddhist society. They lived by the principle of ahimsa, or non-violence toward all living things. The princess found herself at a crossroads. Implementing her stolen technology meant initiating a mass slaughter that violated her kingdom's religious identity. She chose her beliefs over efficiency, issuing a royal decree that forbade the boiling of silkworms and allowed the moths to hatch naturally. The emerging moths severed the silk fibers as they left their cocoons. This meant Khotan could only produce shorter, frayed threads, resulting in a textile that was technically inferior to the Chinese original. We see the impact of this choice in the region's sacred art. The figures on these artifacts are depicted with halos, a symbol usually reserved for holy beings. In Khotan, these women became deities, not for the technology they stole, but for the moral choice to limit its output. This mat illustrates the Silk Road as more than a trade road. It was a superhighway where Eastern manufacturing collided with Western philosophy. This represents the localization of technology, importing a foreign tool and systematically rebuilding it to align with local ethics and values. Historical innovation rarely looks like a perfect copy of the original blueprint. The lasting legacy of the Silk Road was the ability to adapt rigid tools so they could coexist with local humanity. We face modern versions of the Khotanese problem every day. Our society frequently debates when to sacrifice maximum technical efficiency or profit in exchange for ethical peace of mind. We build land-intensive renewable energy grids, accepting a less concentrated power source to avoid the environmental destruction of cheaper fuels. We develop encrypted systems that prioritize individual privacy, even when those protocols slow down the speed of data processing. True progress is not defined by the limits of what a technology can do, but by the boundaries our conscience allows it to reach.